this video, we're going to look at the mechanics of multiplying and dividing with fractions and just establish sort of how that process works. I wanted to start by looking visually at a fraction again. So I've written out the fraction 5/8 here, but I've also drawn it with a circle. The circle is separated into eighths, and I've shaded 5 of them. Now I want to look at what happens if we were to double that fraction. So if we were to double 5/8, what's going to happen? Well, I've drawn the circle now twice, and so you can see if I were to count it up in total, I have 10/8 overall. And the way that we actually can reach this conclusion mathematically is when I have 5/8 and I multiply it by 2. Anytime you multiply a fraction by a whole number, that whole number just gets multiplied into the numerator. In fact, I shouldn't even say it's just a whole number. If it was a whole number or an integer, it's going to get multiplied into the numerator. Technically, the best way to look at this is that it's 5/8 times 2 over 1. And so then you're multiplying the numerator together, denominators together to get your final result. So that's how we end up with 10/8. If I wrote that as a mixed number, it would be 1 1/4. So if you can see here, I took 3 of the eighths that were shaded in the right circle, I moved them over to complete the left circle. And so that's how we can actually go from an improper fraction to a mixed number from a visual standpoint, by filling up one circle completely and then putting the remainder in the other circle. So I've shaded in a full circle and 1/4 of the second circle. Now for multiplication in general with fractions, the rule is always that if you're multiplying fractions, you do not need a common denominator like you would for addition and subtraction. Instead, all you need to do is multiply the numerators together and the denominators together. So here I will do 3 times 7, and in my numerator for the result, that's going to be equal to 21. And on the denominators, I can do 5 times 12, which would be equal to 60. Now this fraction is not yet placed in lowest terms. I can technically divide a 3 out of the top and the bottom. If I divide 21 by 3, I get 7. If I divide 60 by 3, I'm left with 20. So that's how I've now done the multiplication to get this final fraction, and then I put it into lowest terms. And so that's always the way we will multiply fractions. You're multiplying numerators together and denominators together. There is a visual representation for that I can do with circles. It's a little bit more cumbersome to show though in a video. And so if this is something that you're still kind of scratching your head about as to why this works for fractions, I'd be happy to show you, but that's more of an in-person demonstration than a video demonstration. Now division seems like it's a bit of a different problem, but it's actually a little bit more of the same. And if you recall how to do this, there's only one additional step that has to happen with division first. And that's that when you're dividing by a fraction, you can rewrite it so that you are multiplying by the reciprocal of that second fraction. So basically you swap where the numerator and denominator are in that second fraction, and instead of doing division now, we do multiplication. So I have 2/7 now times 3/4 instead of divided by 4/3. And once we've rewritten the division problem as a multiplication problem, we can now use that same rule we used last time. I do numerator times numerator, so 2 times 3 is 6, and my denominator I have 7 times 4, which is 28. And this can be reduced a little bit because both top and bottom are divisible by 2. And so I can end up with 3 over 14. Now, people who are pretty eagle-eyed and good with their mental math may have noticed that back in this step here, I could have actually done the reducing before I did the multiplication. And as a general matter of course, I do recommend to students that they reduce numbers before they make them bigger. So the trick to this strategy is that if I'm multiplying the tops together and the bottoms together, the order of multiplication doesn't actually matter. So 2 times 3 will be the same as 3 times 2. I can technically swap the ordering here, and I really fundamentally haven't changed anything. So see how I swapped where the 3 and the 2 were in this multiplication statement? Nothing's actually changed here. If I do 3 times 2 on the top, I still get 6. 7 times 4 on the bottom still gets me 28. But now if you look at the fraction on the right, the second one, I have 2 over 4. That I can actually reduce right now by dividing top and bottom by 2. And I end up with 1/2. And now if I multiply the numerators together, I do 3 times 1, which is 3. And then the denominators I do 7 times 2, which is 14. And so I personally like to use that strategy more because I make my numbers smaller and easier to manage in my head. I always recommend to students, if you're ever doing work like this without a calculator, as we will be for the early fractions practice, if you're ever doing work without a calculator, it is so much easier for you in the long run to make your numbers smaller first before you multiply them back out again and make them bigger. So for the sake of making your mental math really quick and efficient, that's what I would recommend. It might take a little bit of practice to wrap your head around that because it's not always something that is taught the first time you learn fractions, but I promise you, the more you practice with it, the more it will help you in the long run.